today is the last lecture. You know that. Next week, you will have final exam. As we had for midterm exam, you will have 3 days, 3 time slots, each, I think, different days, right? It starts Wednesday. So Wednesday evening, Thursday evening, Friday evening, if I remember correctly. Not evening, yeah. Wednesday evening, Thursday, this time, or Friday evening. So you may be able to choose one of those. And if you do not take it, then there's no makeup because we do not have time. Particularly, I do not have time at all. Right? I'm going to leave Saturday, so I have to report the grade before that. Okay. This is our cybersecurity website. Where is my? Okay, here. All right. I keep improving, right? It improves. Do you like? If you do not like, then you can let me know so that we can upgrade. This is the T-shirts that we created. I think only one issue received. By the way, issue, I found out real big ones. If you want to, I can get you. If you want one more, I can get you. That T-shirts will be given to those who participate cyber skill competition, and possibly at some other events we may be able to distribute. So I want you to join. Yosef, I think you and Delvine will participate, right? Cyber skill competition. So before you leave today, I will give you the T-shirts. Do you meet Delvine personally? Yeah. Oh, where do you meet? Not Irish pub, but...
No, he lives in Brooklyn.
Okay. So, but you live in New Jersey, right?
No, I live in Brighton Beach. He lives in Brooklyn, not too far from me.
Oh, I thought you guys lived in New Jersey. No. Okay. How was your meeting last week? You guys had international...
He didn't come.
He didn't come. We have an officer there. How many students?
15.
Oh, 15.
For the cybersecurity competition, as our project, can we build a Raspberry Pi?
Yeah. What do you want to do?
We're going to send you the list of the parts we need you to order.
No, first I need to hear what you want to do. Not the part first. Okay? We'll do that later, okay? We do not have time. Okay, this is what we were talking about, this cybersecurity competition 2017. In physical meeting, Tuesday evening, we had 2 teams set up. And I think Yosef and Delvine will be another team. You can recruit more members, okay? And after this semester, the first meeting will resume the 3rd Tuesday evening. If you come on that Tuesday evening, then we will set up another meeting time, another time that you can make. Okay? During summer, we don't necessarily meet Tuesday evening, right? We can meet, we will discuss whenever you want. So second Tuesday, I'm not going to be here because I'm going to be in the conference presentation. The first week is next week. So next week we will have another meeting. Okay. So that is that, and another thing here, I wanted to. I already had enough enrollment, but if you are interested in, this is only for graduate students, IASP 595. If you click detailed here, is that the topic for 595 in this summer. I was trying to develop the course in one way and then another way, and finally I decided this. In this class, I'm using, you guys need to use Raspberry Pi. On Raspberry Pi, we start with Ubuntu, and then Kali, and then all kinds of hacking tools that we implement, and sometimes we will do development. Okay?
595 is an online class?
Could be available online or on site.
For the summer?
Yeah, for summer only.
No
Lecture.
internship. No internship.
No, this is a class.
Just a class?
Yeah.
Oh, perfect.
This is a 50%. Lecture type is this, 50% or less lecture. I'm going to give you 50% or less. Close to 50%. Another 50% is your work. Okay? Topic that we want to discuss is this. Those who do not have a Linux experience, this is a good course that you can gain Linux command skills. Linux is a must. If you want to work on cyber security professional missions, then Windows is, everyone knows it, Windows. And Windows is not secure. Windows is not good platform to run services. Linux. So you need to have a Linux command skills from installation to services. So we will start with the installation. Two types of Linux will be practiced. Ubuntu. I mean, both are from the same development, which is called the Debian. So, tens of years ago, the first generation of Linux was Debian, and distributor of Debian, or extension from Debian is it's in one way Ubuntu. So we will work on Ubuntu. Ubuntu is similar to Ubuntu, but it is called the Raspbian. So we'll work on Raspbian. Okay. If you buy 32 gigabytes SD card, then one SD card will be, did I say here? Yeah. Two of 32 gigabyte SD cards. One for Raspbian and another for Kali Linux. And Kali Linux, and in both ways, we'll set up Wi-Fi so that you can connect to our router, or you can do that at home. Both Kali and Raspbian. And Kali for Raspberry Pi version is not really a complete set of cybersecurity tools. There is no complete set because of the size issue. So we need to selectively install one at a time. For example, Metasploit. We will just start with the Metasploit installation on Kali Linux, or we could do that on Raspbian, and then we practice that.
Raspbian, the operating system Raspbian, how is it useful? How is it? I never worked with it. Does it have any added value?
First of all, the value for that is it is portable, of course, because it is running on a Raspberry Pi. Okay, and very small size. So once you have some small systems, then it can be embedded in any system. I mean, if you run on, for example, some manufacturer company, then having that technology, you can minimize it and put it on, for example, some place, maybe in automobile or some electronic appliances, whatever you want to do. Okay, it's not like a desktop server. Okay? It's not that. It's a small device. Number one. Number two. So it can be minimized. Your attack tools or defense tools can be minimized on that microcontroller unit. Okay? And number two, microcontroller unit or mobile technology will be the future computing power. Okay? Remember that I said NEC or fog computing? As opposed to cloud computing. Cloud, there is big cloud up in the air, but it's far from us. We don't feel it much. But fogs all around. Similarly, our mobile phones all around. Computing power of mobile phones will be enlarged, so will be stronger and stronger. So your mobile phone and my mobile phone and some of the sensor technologies all together will be a very strong computing power. Therefore, it will be a strong attacker or could be a strong defense. Okay, that is the future. So future cyber security will be on that level. So we need to practice a little more. Hey, check.
And then the Raspberry Pi, does it come embedded? The Raspbian operating system, it comes embedded in the Raspberry Pi, or you need to install it?
We have to install it.
So in that case, I can have Windows and Kali dual boot on the Raspberry Pi. I don't want to have Raspberry.
No.
I have Windows
No,
and
that is
Kali?
no. Raspberry Pi does not have storage.
What?
Storage,
Storage.
right?
SD
You need to
card.
have a small SD card and make it bootable. So when you turn on Raspberry Pi will rely on that bootable SD card. So to make a bootable SD card for Raspberry Pi is 32 gig. If you have 64 gig, possible, but Raspberry Pi itself look through 32 gigabyte only maximum. Currently, may have a bigger version, maybe next year or next month.
What
Who
about
knows?
the RAM? What's the maximum RAM?
1 gig.
1 gig, that's it?
Mhm.
You cannot go further than 1 gig?
No, it's not expandable.
How are you going to run Kali with 1 gig?
That is the reason Kali removed many tools.
Because some of the tools needs a lot of memory.
That is the reason we need to install and distill multiple times. We start with a Metasploit and all this, okay, in this way. What else? And in next class 555, I have Raspberry Pi. You will see it, but it has a Raspbian only. I have another SD card. It has Kali. We'll do that later. Okay, this is new course for the summer, if you like. By the way, you two guys, have you heard any from our IT? I sent them, but I haven't met them physically in person. If I see them in the street, then I will definitely ask, remind them. Okay, so we'll see how it works. All right. This is good, right? This is a big improvement. Jobs and placement. Some internship positions and corporate positions, government positions, research positions. I didn't make it yet, but some of those. For example, internship position. There is a AmeriCare, Greenwich, Connecticut. It is being published. If you want to, you can do also. That is intern IT, summer 2017. If you are interested, you can apply for that. I will keep increasing this. And Cyrus XM, this is a radio station. If you want, there is also some positions, permanent position and internship positions available. Senior Information Security Engineer, this is in DC locate, not here in New York. So if you see here NY, DC, there's different kinds of locations, so you can find it also, right? So where is my mouse? Here, back up. And some of our faculty members, right now only mine, all others, if they give to me, then I can have them theirs. Mine is, if you want to see me, this is me, this is, so if you want to contact me, whatever, this is my publications. One of my publications that I want to present.
The next month.
Yeah, 2 weeks from today. 2 weeks? No, not 2 weeks. 2 weeks from today, then are already done, right? In 10 days. There's a leveraging sensor data content to assure sensor device trustworthiness in mobile edge computing. That is mobile edge. And in summer, I have another class, ANN-based collaborative sensor calibration and GA approach to sensor mutation management. Probably you may not know ANN or GA, but I think yourself, you should know. What is ANN and GA? Some of you, you didn't take it with me. Oh, I have, this guy's still alive? Flies? This one wants to share water with me. No way. Oh. Here it is. Jenny. Close your. Okay, anyway, so the guy wants to drink water with me. Still good, this water. If something happened to me, you are the witness. Fly case some charm. And what is the ANN? Yourself, you should know. I know you know. Artificial neural network. Artificial neural network. You learned it, right? You learned it.
Yeah.
Have you practiced some of the code that I did in class? You were in online, so probably you didn't. We covered that in 520.
520? 520 is data mining.
Mm-hmm. The last module of data mining at that time was ANN, Artificial Neural Network.
Do they have any assignments in it?
If there is no assignments, then don't do. You know? Because that was the last module, so I didn't give to you. Probably I'm gonna do this early. But if I do this early, then the students do not understand it really, because this is a neural network. What neural network is that it's almost endless repetition of for example, neurons. Our brain is a collection of neurons. Neurons are interact with other neurons with synapses, right? So a lot of interactions. That is simulated in computer, which is called the artificial neural network. So using that artificial neural network, how can we improve the calibration of sensors? Okay, and GA means genetic algorithm. Genetic. What is genetic? It's like gene, right? It's like human's biological energy. Therefore, there is a mutation. Sensor network. Sensor network consists of sensors and microcontrollers, right? Sensors, a lot of sensors. But lifetime of sensors is not the same as lifetime of, for example, server here or your desk, your laptop. Lifetime of a laptop usually 4 years, right? Lifetime of sense, again, your laptop may die if there is no power, right? In that sense, usually when you charge fully the battery, internal battery of your laptop, then it'll last about 24 hours, right? So lifetime of your laptop, if you let it go on its own, then only 24 hours. Similarly, sensors, 24 hours. It depends on the amount of data that you want to transmit. Data transmission is the killer to the energy. If you simply collect sensor data, then it doesn't consume much. But when you send out the data, then it's consumed dramatically high. So anyway, so mutation is very common. In the network, some sensor dies because of low battery. Okay? Some sensor came back on because recharged. Or some sensors may be sneaked in because of that is attacker. Or some sensors, it's a lot of mutations available. Okay? So that mutation is very similar to the mutation in our body, in human, in living objects. So genetic algorithm is the algorithm that describes very nicely some offsprings based upon the parents. Okay, mother and father. Then you have children, right? So mother's gene and father's gene are crossover. It is called a crossover, right? Crossover, so that your gene, part of the gene that you have comes from your mother, another part comes from your father, and some of the gene may be mutated. So you guys are not really behaves half from your mother's side, half from your father's side. But if you see yourself or your parents see you, then they may think that, oh, this guy, I didn't understand my son. How come he behaves that way? Then they think that maybe we mutated. That type of things. Okay, that is happening in sensor networks. Anyway, this is my. Okay, for this class, today is the last class. It's data management in Python, revised a few days ago. Okay, so earlier version is not the one that. I mean, this is a lot more than that. For example, this is a database, right? So we looked at that. Okay, database manipulation. That's what we did the last time, right? So we connect the database and using cursor, right? As I said, the cursor is a file pointer to the data sets returning from your SQL execution. So initially it points to the first element of your returning set. Okay? You can say first record. When you deal with the first record, you want to deal with the second and third and fourth continually. Therefore, you need to have a label to that cursor. Okay? So execution of that, then you will have that cursor. So you need to fetch. If you do fetch all, then cursor will fetch entire record and all the records. If you say fetch one, then it fetch only one. So this is what we did the last time, and we also did multiple execution, right? All right. Here's the thing that I want to do. I want you to look at example 4.4.6. And two codes given, left column and right column. I want you to take a look and compare those two coding list. I'll give you 5 minutes. Shall I ask you to compare those two coding lists and see how they are similar? Okay. Example 4.4.6. So you don't have. There is a desktop. You may be able to use. Bound. Who will explain? Bishu, can you explain the difference or similarity of those two coding lists? First of all, similarity is this. Similarity. They use two tables, right? See here, select everything from two tables, students and departments.
The difference is that the first one is going to show you all the attributes, all the table of students and departments, and the other one is going to show you everything, but where major is going to equal to department name.
Right, that is correct, but can you say a little more? For example, I said it's a Cartesian products, and here I said join operation. If those two names give you some hint.
One is Cartesian, it's multiplication, and the other one is projection, which means only going to show me where the major equal department document.
What is join? What do you expect from those two tables, students and department? If we say join, students join a department, what does that mean to the database?
It means that the result is going to be one table with the two tables, students and department together.
Joseph is smart. What I mean by that is, his statement is not really 100% accurate, but his statement is the statement that I can say that is not right. His statement is somewhere in the middle. So in part, yes, you're right. But I wanted to say more precisely the way that I want to hear. Do you know what I want to hear? What I want from you is that by looking at this, if you do this with no condition, so one here, left hand side, there is no condition. Right hand side, there is a condition. Where condition, right? In join operation, where condition is a must. This is not optional. This is not optional. When you want to join, therefore, if you want to expect to see which students is majoring what department, if you want to see that reality, then that is the join operation. And if it is a join operation, then you need to have join condition. Join condition. You must specify join condition. Okay? If you forget to specify join condition, by simply providing two tables in that from close, what happens? It gives you all possible combination. Somehow, Joseph was right. He said, production, all matches. So if you are in a student table, if there are 100 departments, then you will appear 100 times. So you will be in every single department, which is not true, right? That is not true at all. So that doesn't reflect the reality. But it includes the reality. It includes, for example, these guys are really the guys. For example, Kevin is in CSEC, James in CSEC, Adam in CS, Kelly in CS, Bob in CSEC. If you see here the result, then why I have so many columns? Because I want to project all, which means star. All means all attribute from students, all attribute from the department. So I have all attributes. Okay? So I have some of these attributes, those attributes are the same. What would be the same? Student major and department name, they are the same. Look at this. Kevin in CSEC, that is Kevin's major. And then another column, there is a CSEC, which is the name of the department. John is the department chair, and this may be the department budget, 1234.56. Okay? So, if you want to see the reality only, then this value, major value, and the department name should be the same. That's what you need to describe here. Major, which is a student major. Department name, this is a name. So department name should be the same as student major. If you see here, name of department, you brought in department dot, but you didn't do here major. Why? I have here dot notation, but I do not have here dot notation.
Because
You could have dot notation, of course, but I eliminated that. Elimination is okay because
you selected from student, so you don't have to do the dots. Because it's pointing on student. Select star from student.
no, that is not the reason. Name, if you don't do department dot name, then there is another name, student dot name. So there is ambiguity. But major, there is no,
It's the only one.
yeah, only one available in students. When you define, see here, department name, chair, and budget, and student name, major, year, GPA. So if you say name, then we do not know. When you have two tables in one SQL statements, then there is an ambiguity. You will have an error. Okay? Probably I do not do practice today because we do not. If we do, then we may not be able to cover all that I prepared, all that you may need to know. So this is one thing. So if you see here, this is a Cartesian products. So don't. When you want to see the reality, then you need to have a join condition. Okay, that is one thing that you have to know. Then another thing here, why do we need this then? Why do we need Cartesian products? Why don't we create the language, SQL language, by having only, if we have two departments, then we simply say two departments, we assume two departments join. There's a join operation. So without having to add this join condition, anyway, intention for this SQL statements is join. So why not assuming this? Why should we state this explicitly? Therefore, without that, then we will have Cartesian products. Why? That was my question. That is an implementation question. initially as when SQL was invented. Okay. And also thereafter, when you have more than one table in the from closure, like this, student and departments, two tables appear in the from closure. It's not only for join. You may match not only this department name and major, but you could match anything that you want. So more flexible. You can say, oh, is there any GPA that is greater than a year? So therefore, sophomores, if sophomores GPA is greater than 2.0, then I want to see. If juniors GPA is greater than 3, because year of junior is number 3, right? We could make condition like that, right? So more flexible conditions can be expressed. Okay, so a lot more, and more critically, in SQL statements there is a minus set minus operation provided. Set minus. If you want to do minus, then you need to have entire set, all possible productions. Therefore, you can say, for example, who are not involved, who are not majoring computer science. How do you know them? Who are not majoring computer science? You need to have an entire set. Therefore, you can see that kind of negation operations possible. Okay, set minus, set difference, or negation, that can be possible only if we provide Cartesian products. Okay, moving forward, and all others may be okay. Integrity, database integrity. I'm going to give you a demo for that. Okay, integrity. What is integrity? Data integrity or database integrity. Why it is critical? Many cases. When you send the data over the transmission, there may be some modification possible. Bank 1 send the data, okay, $50 million to another bank, but in the middle, if data tweaked, then the bank may lose $50 million. So before the recipient opens the data, recipients check the integrity of that data. Not only that money issue, but also by modification, somebody add some virus data there, right? Like Trojan virus embedded in the data. So all kinds of modification can be detected by checking integrity number. We call that hash number, right? There are two kinds of hash numbers widely used. MD5, sum, and SHA-256, sum. Sum means a hash, okay? So MD5 hash or SHA-256 hash. Anyway, that's hash numbers. Hash number is generated. If you use MD5, see here, both are available in hash library. Hash library dot MD5. This is for MD5, and another one here, hash library dot SHA-256. Okay, two different algorithms, and each algorithm generates different number. And size of data usually 32 byte long, right? Doesn't matter the size of input file or data, it always generates 32 byte long hash numbers, but could be more than that. So I ask you to do some exercises here. By executing this, if you say S, that two options, S or F, okay? Those two options can be found from I forgot to write, or command selectively string text or a file. Note that a parse take multiple command options. There is an example somewhere, but I didn't point that out. But anyway, the idea is that you can use the module argument parser. So parser needs to be involved. So I'll give you an example. I mean the demo. So this coding list works as is. Only the exercise positions, exercise is the extension from this code. If you extend this code to take selectively S option or F option, then you will have this. Okay, so let me give you demo. And so reduce a bit. Simply reduce. Okay. So an MD40XT or Intel. MD4 txt. And then if you put here string only, then you can say whatever you want to say will have a hash value from this MD5 some algorithm. Okay, and if this is a string, okay, one entire string, then see what is hash code. Hash code is this: the MD of text, whatever the text from here there, okay, quote equals 28, whatever that is, right? Similar things can be done selectively. If you want to make that using some of the F. So in order to find that, let me bring up some of the documents, downloads. Okay, I downloaded something. Is there a big file? Okay, Kelly. Oh, this is big. Kelly to the. Okay, this is Kelly. What I'm going to do here, F, and then C colon backslash users jun downloads, and then Kelly dash 2.1.2 dash RPI, so Raspberry Pi 2.image.xz. Okay. That's a big file. Size of that is 1 gigabyte. So it's compressed to 1 gigabyte file. Okay, that is that, right? How many bytes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think 16 bytes. 11, 12, 13, 14, 15, 16. 16 bytes long. It's not really 32 bytes. Let's see, similarly, if we use char, okay, this. So I'm going to bring up that. Same file, but using char. Integ for char underscore f underscore t.py. Okay, this is MD5. This is a char. The hash code for char is longer, right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So double. 32 byte long hash code generated from SHA-256, and MD5 generates 16 byte long SHA codes. Okay? When you download some of the code, then they usually provides you the hash code, so that ask you to verify the version you generated, version you downloaded, is the version that you finally received, right? That's what they usually provide you for you to check the integrity. So this is data integrity. And then another one is a data cryptography. Data cryptography. Is the same guy? Fly? Huh?
He came back to life.
How come? Okay, cryptography. What we want to do is that there's a sample code that generates the ciphertext and original text. For example, if you look at this code, AES encryption algorithm, right? Advanced encryption. This is symmetric key, right? Symmetric encryption. So, which means the same key can be used for encryption and decryption. So AES object is created, that is called the OBJ. Okay. When AES object is created, we give them AES the key in 16-bit. This is one of the restrictions. If you use AES, then you need to give 16-bit. And then same size bit is used for initialization vector. So you have an initialization vector, and then key together can be generated. Together will be used to generate the objects of AES. So that is OBJ. So message is hello, sign on T. Message should be also the same size, 16-bit. So every 16-bit you may be able to generate. So this is block encryption. But if there is a streaming data, then what you need to do is that you need to make a block each every 16 bits and encrypt it and send out. Then when recipient receives it, it receives the cipher, the same key. If they share this object together between the two parties, then they can encrypt and decrypt very efficiently, right? Only the issue here is that if you lose this, then you lose everything, right? Because anyway, you need to share this key and ID together. But anyway, in that way, you can do encrypt and decrypt. So this is the sender side. So encrypt it, right? And at the receiver side, if you have the same exact same key and same ID, then you can decrypt it. Okay. So first output is a ciphertext. It says a ciphertext. This ciphertext is the text to be transmitted at the recipient when it receives from here there, right? This is the recipient's code so that you can see it back to the original message. Then that is hello sign on T. This hello sign on T is the message that sender wants to show to you, right? So this is general encryption things. But so far, this guy has nothing to do with the database. How can you apply this to database? That is what we want to do here. In database, two things that we use. Did I say that? Somewhere, yeah. AES. Oh, this is AES. Similar encryption can be done by Phonet, which is provided from the package cryptography. So Phonet, AES or Phonet may be able to use for database encryption, but the code itself, here is the thing. Okay, this is the budget, right? 12345 .99. That is encrypted by Phonet F. F is right. I call that F, right? This is Phonet with the key. Okay. And I call that object F, and using that object, I encrypt it. Encrypt one of attribute value. If department budget is a sensitive data, sensitive attribute, then you need to encrypt it. So when you save database, encrypt and save. Okay. So if you simply So what the database contains for that sensitive attribute is encrypted cipher text. So if there is an attacker intrude your database successfully and issue SQL statements, when that attacker receives the result of that SQL execution, still that attacker cannot see the value. Why? Because intrusion is successfully done, but data decryption is yet another thing that attacker needs to do, right? So database encryption is very, very important. The double barrier, right? There's multiple barriers. For network professionals, you set up all the infrastructures, so there's the firewalls, and all network devices has some tools to protect. So some strong attacker passes through that. So attacker comes in the database. So database has what? Login name and password, right? So let's assume that database attacker has also login name and password. So successfully in our database. If our database has encryption tools implemented already, therefore some sensitive attribute values are encrypted, then attacker, although attacker comes into that last end, he cannot read it because it is encrypted, right? What he needs then is key. if there is a AES symmetric, then we can, once we know the key, then we can still receive it, right? But this 4net ones is that it needs two things. Not only the key, see it has a key, right? It is a key. Not only that, it needs a salt. Salt is in food science. Salt is very, very important component, right? So that you can keep your food longer. With no salt, then will be what is that? What's the name of that? Food will be
The database like SQL Server or the Oracle. They have the one encryption method for encrypted database.
no. You can select selectively. Database engine, for example, Oracle equips tens of different algorithms available for you to choose. So in this case also, salt is generated randomly. What is salt? Why we need salt? Let's go back to that scenario. Strong attacker comes in to all the way to in front of that database, so that issue the proper SQL statements. So receives it, but some of the attribute values are encrypted. Okay. Then what that attacker would do? One of the possible ways is that using the dictionary and try to decrypt it, right? Because the key is not known. If it is the AES case, AES algorithm. Remember the earlier algorithm? AES. The key is needed. In this format, needs salt. Why do we need salt? To protect from dictionary-based attack. Salt is, look at this. If you see this code, salt is generated from this operating system. So depending upon the operating system, there is a random number. It is generated randomly. Generated randomly once. It is called nonce, N-O-U-N-C-E, right? Those who knows a little bit of cryptography, anybody took cryptography course? Then you probably know nonce, N-O-U-N-C-E. So once created and no more used. So once, okay? That protect that. And this nonce is, in this implementation, I saved it in a database, and key is a database to demonstrate that we encrypt it and decrypt it. Okay, so if attacker comes in and successfully receives the result of SQL execution, then attacker receives this. This is the encrypted text. Only that he can get it the right value if he knows the key and nonce. Salt.
So salt is like an extra key which you're adding to it, an extra layer of protection.
You may right. There are some mixture. Could be extra key, but it is not a key, right?
This kind of layer.
Yeah, different layer of.
Can you be more specific about salt? How is it?
Yeah,
created?
I'll show you. It is Where is? Okay, here. So, example of salt. I think I changed it here. Yeah, this is a salt. Key, for example, this is key. PIP install cryptography. Okay, this is the key. However, salt, this is automatically generated.
It's from your operating system or it's your
My operating systems,
your operating
right?
system. And one
From
time.
from Python.
Okay.
Only one time, but I saved it. Otherwise, I cannot decrypt it, right?
Yes, and this one gets mixed with the message.
Correct. No. Save it separately.
It's separate.
Right.
So
So
why is
if
the attacker need to know what
if that person is the proper user, then you can provide that salt that you secretly saved, so that he can use that salt.
how do you know if this is the proper user or not? Is doing an SQL statement?
No.
Is doing an SQL injection?
No, this has nothing to do with the database. That is one extra one, right? You need to have user's credential and everything, and if that is a proper user, then you can release that.
So how can you know it's a proper user? Because when you want to crack it
that has nothing to do with this class. Okay, database class has nothing to do with the Python. You may need to learn from somewhere. If you come to 595 somewhere, then we can discuss about that. Simply, if you use Oracle, then Oracle, when user enter, then Oracle uses session data from the session layer of that OSI 7 layer. From the session layer, when you log in the database, then from the session layer, you can capture all the information about the user login, user ID, user role, user IP, and everything about the user secretly. It's not shown to anyone, so that you can check if that IP is the IP that you and that proper user agreed upon. So you need to check IP number that you trust to,
It's IP
or
chain.
some.
IP chain.
Then you have to, another process, you have to verify that IP is that you trust. There's a trustness issue. Has nothing to do with this. There's another step. Okay. Remember that usually some banking system, internet, if you use your system device, then initially they don't allow you to, right? Do you have that experience?
Yeah.
Right.
Exactly.
If you change it, cell phone, for example, so new cell phone, you used to access your banking systems from your cell phone, but if you change the new cell phone, then initially they protect you from accessing, and there is another process that comes in saying that, are you really? So another steps, right? What is your first mother? No, not first mother. Some of the security actions, and then some other processes, new trustworthiness needs to be established. So once it is established, it means once that user credential is saved on that database, there's a different database. So from that database, if that person is okay, then you can provide this salt so that you can access.
That's what I'm saying. You base it on his credential to verify him. So then you give him the salt.
Mm-hmm. So now you know what salt is, right? This is a salt. You cannot copy it. You can save it, but you cannot copy it. This is available only on that server only. Okay, I'll give you a demo for that. This. Okay, another demo. So database encryption. This section is for cryptography. Okay, so using that in database encryption, similar for that, and then here we have database, right? Let's say departments. We create departments, and then encrypt if that is department. Okay, we have three records in the departments, and CSAT departments only encrypted. So token here is the outcome of that encryption. Okay, that is this. And then budget that is encrypted. If we want to decrypt it, so select star from department. So fetch all, and if you fetch all, then what happens here is that CS Nathan, CS department Nathan has a department budget number, and CSAT John department budget is encrypted, and the math department budget is shown from SQL statements. But if you decrypt it properly, then CS John's budget is shown because it is decrypted. Okay, so this is a small sample encryption and decryption of the database. In this exercise, I ask you to do entire. So you have a salt key. Okay, so CS Nathan budget encrypted, math Mary encrypted, and CSAT Jerry encrypted. When you access it with no decryption, then it generates like this. If you decrypt it properly, then it is decrypted in this way. So that's what I want to show to you. Okay. Okay, here. Let me see if you have that code DPT1 encrypted to Key2. DPT1 encrypted. I think this multi. I think I changed it. So DPT1 crypto create multi.py. So all the records, when it comes to that sensitive data, that is encrypted. If not sensitive data, then it is just as a text, right? Department name and department chair, like this. Okay. For this database, if you want to select, this is select decrypt, select deselect tool. Simply dpt to select one. Right. As is, you can see only cipher text. But if you select one only, then you can do this. But if you want to do all together, that is also possible. That is another code similar to that, but DPT2 cell decrypt. Then everything here, right? So all are decrypted. CS Nathan, that and that and that. Okay. I think this is it for the database security. So all can be done in Python. Okay. Right now we use a simple database engine. As I said, it is not really engine, but anyway, that is it's nothing but database, right? SQLite. So we use the SQLite. But you can do MySQL, Oracle. Oracle does not provide very friendlier to Python users. As far as I know, a year ago. Last year, in summer, I offered the database security. That time we used the Oracle. Oracle provides Java access. With the strong technical support. Why? Oracle is the vendor for the Java. Java was the language developed by Sun Microsystems in 1995. But the Sun Microsystems was acquired by Oracle about 10 years ago. So all the Sun Microsystems products are now handled by Oracle. The products of Sun Microsystems was Java. So there is an episode, Oracle wants to charge Java. But Sun Microsystems, one of the conditions of that acquisition was that Sun Microsystems says, hey, although you acquired our products, you should continue to provide Java for free. So Java is still free. Together with the Java, MySQL was also the products of Sun Microsystems. Is now owned by Oracle. So MySQL is still free. Therefore, Martins, you use MySQL, right? For free. That's the reason Oracle opened the door widely to Java developers. Java SQL embedded Java programming is highly recommended by Oracle. Any question? Okay, this is the end of my lecture. I'm not sure how much you learned. Basically, Python is the most important language for you. So I covered the extension of Python for various different applications, from the network application to the database application. A lot more than this available. Okay. So I continue to upgrade my textbook as I teach you most of. So I'm also happy. Only the portion of operating systems, network operating systems, and database systems. I may extend my Python book to different angle if I teach some other stuff. But in this semester, I used only those three. Okay, so hopefully you may have some idea, and also you may feel the strength of Python programming language. You can do anything that you want. Okay. The last one that you need to do is final exam. There's no project, no additional homework assignments. There's a lot of homework assignments available in this textbook, but I didn't ask you to do. So all the exercises are homework assignments, but I didn't ask you to do. Final, everything.
From the beginning.
But if I said, then from network, operating system, and database. But there, Python also available. So anyway, you need to know Python. If I say everything, that is too much. If I say after midterm, then where there are a lot of Java stuffs. Therefore, but I'm not going to ask you Python itself. Okay, the language itself. I'm going to ask you. If I ask you Python, then that question comes with the concept of those three subjects: network, operating systems, and databases.
That's included for the final exam?
That is the final exam. Right? So about the 50% of concept, more than 50% of the questions from concept, and up to 50%. So less than 50% is a little bit of implementation. I'm not asking you to implement this. No. Slightly, right? Fill in the concept. Fill in some, but open book.
For the other class, only the final exam is answered. The physics will be.
Yeah, there's no written exam. The other. Okay, let's close this.